On this example, we have a linear divided by another linear. So let's start by finding the vertical asymptote. The vertical asymptote is the denominator. The denominator will tell you what the vertical asymptote is. That's where the function ends up being divided by 0. So basically, the asymptote tells you what value is to be avoided. So we end up with a -2. So let's select the vertical asymptote and sketch it at -2. Then we're going to find the horizontal asymptote. And the horizontal asymptote is about seeing what makes a difference in the behavior. In this case, because we have a x and an x, they both have the same degree. The difference maker is going to be the coefficient. In this case, the coefficients are 2 and 1. So because we have a tie, we're going to have to set the difference maker will be about the coefficients. That means that horizontal asymptote will be at +2. So we go here to +2. And I would suggest that you go for the y-intercept and the x-intercept as well to get a couple of coordinates, a couple of easy coordinates. So the y-intercept is about evaluating your function with 0. You're pretty much asking yourself, what value would I be getting when x is 0? So that's basically 2 times 0 plus 3 divided by 0 plus 2. So every x term will end up as 0, and you will have 3 halves. So that gives you the coordinate 0, 3 halves. And the x-intercept is the opposite, pretty much. You're asking yourself, whenever y is 0, what would happen to the x? And if you do it all the way through, you're going to notice that it's all about the numerator, because this is basically y equals 2x plus 3 divided by x plus 2. And if you're stating that y is 0, automatically the denominator will become 0. So the x-intercept will be about the numerator. X plus 3 is equal to 0. Because if you have that as a denominator and you set that fraction equal to 0, once you multiply everything by x plus 2, you're going to end up with 0 times x plus 2, and basically with x plus 3 equals 0. So if you divide, if you solve for x on this one, you're going to end up with 2x equals -3. And x equals minus 3 halves. So you're going to end up with -3 halves. So let's go ahead and plot those points. The first one being 0, 3 halves. And the other one being -3 halves, 0. And because those 2 points are on the right-hand side of the vertical asymptote, we need to find a couple of points on the other side of the vertical asymptote. So anything on that side, -3, -4, it's up to you. So I'm going to use -3. So that would be 2 times -3 plus 3 divided by -3 plus 2. That is going to be -6 plus 3 divided by -1, you are going to end up with -3 divided by -1. So that's +3. And let's find another one. We could use -4. We can use -5. Very much up to us what we want to do. So let's use -4. And that will be 2 times -4 plus 3 divided by -4 plus 2. That's gonna get you a -8 plus 3 divided by -2. And finally, we get a -5 divided by -2. And that's 5/2. So your coordinates are gonna be -3, 3 and -4, 5/2. So let's see if that works. Let's start with -3, 3 and -4, 5/2. And I imagine that you have an idea of how this graph will look, but let's select graph a function, and there you go. That's how the graph will end up looking. Once again, vertical, horizontal, y-intercept, x-intercept, and another 2 coordinates that are up to us as long as they are on the opposite side of the asymptote.